This video is about fundamentals of organic chemistry. So the question asks us to write out the formula of the organic compound 2-aminoethanoic acid, as well as methoxyethane. So the concept of this question is the IUPAC nomenclature. So firstly, we have the organic compound 2-aminoethanoic acid. We first need to look at the type of organic compound as well as the longest carbon chain. So here we can find that in the part of the name which says ethane, and that tells us the longest carbon chain consists of 2 carbon and it is an alkane. So we can draw that out first. So we have 2 carbon and it's bonded by a single bond. Next, we look at the suffix of the name. So we have oic acid, and that tells us the functional group of this organic compound. And this particular functional group indicated by the name is the carboxyl group. So on one end of the compound, we will draw out the carboxyl group, which is a double bond to oxygen, single bond to oxygen, and then oxygen bonded to hydrogen. Next, we look at the front of the name. So we have 2, which means on the second carbon, which is this one right here, we will have the substituent group, the amino group. So we can add that in, and the amino group is NH2. So we have a carbon bonded to a nitrogen bonded to 2 H's. And then we can complete this compound by adding the hydrogens, and we have the finished organic compound. Moving on the second question, we have the organic compound methoxyethane. So again, we need to look at the type of organic compound that this is in the name, and oxy tells us that it is an ether. So we can draw that out. It has an oxygen in the middle bonded to on either end. So we first need to look at the longest carbon chain again. So we have ethane, and that tells us there's 2 carbon as well as it's an alkane. So on the right side of the oxygen, it's bonded to an ethane. So here I've drawn it out. And then meth tells us that there's only 1 carbon, and that will be our substituent. So on the other side of oxygen, we will draw out this portion right here, and we have the completed organic compound.